Okay, hi all. So today in this class what I am going to discuss is the CET questions based on relations, functions and sets. So if you go through what previous year question papers, so in 2014, so they have asked 8 questions based on this sets, relations and functions. So in 2015, 2016, 2017, 2018, 2019. Okay, so if you go through there in 2014 8 questions, in 2015 6 questions, in the 2016 3 questions, in 2017 5 questions, in 2018 3 questions, in 2019 again 5 questions. So if you go through there, on an average 4 to 5 questions will be asked. Among these 4 to 5 questions, the questions based on the word counting technique of the word, this sets and relations and functions are very much important, right? So definitely 1 or 2 questions will be there totally based on the counting technique of this sets and relations and functions. Okay, if you go through all the today all the video, so you are going to get the answer there. Okay, I will start with the what, the set A. So if the set A is having what, n number of elements, okay, then the number of subsets is given by 2 raised to what, n. Okay, so this is number of subsets. So there is one more thing which is called as power set of A. Power set of A means the number of subsets will be written in the set. That is nothing but set of the number of the subset, or set of the subset of the given set is called as power set. For example, number of elements in the power set will be also given by, so is equals to what, 2 raised to n. Okay, so suppose they may ask you that. So they may ask you that if the set A is having what, 5 number of elements, then how many number of subsets? So how many number of subsets means you are going to write. So 2 raised to what, 5. 2 raised to 5 is I think 32. Okay, so if they ask you how many number of elements will be present in the power set, means number of the elements which are present in the power set is also same, 2 raised to 5 is equals to number of how many, what, 32. Okay, so if I consider the set A is the null set, okay, that means number of elements in the set A is what, 0, means there are no elements which are present in the set. So if they ask you a power set having how many elements, so power set, number of elements in the word power set is what, 2 raised to 0, that is nothing but 1. If they ask you number of elements in the power set of A, okay, what you have to do is, here already 1, then you have to write here 2 raised to 1 is equals to how much, 2. So if they ask you number of elements in the power set of A, okay, then the number of elements will be present here is 2 raised to what, 2 is equals to 4, and it continues. Okay, so this is how we are going to find the what, so number of the subsets. Okay, so if you go through the what again sets, there are famous questions which will be asked based on the formula n of A intersection B is equals to n of A plus n of B minus n of A union B. So that is what we are going to discuss now. So the questions will be asked like this. The formula is n of A plus of n of B minus of n of A union B, which is equals to what, n of A intersection B. Okay, so you can interchange this also, n of A union B is equals to n of A plus n of B minus n of A intersection B also you can write. Okay, so better don't go for this formula, so better to solve the examples based on by using the what, Venn diagram. So if you see the previous year question papers, so they have asked you some questions based on this, that is what we are going to discuss now. Okay, in 2019 one question they have asked that if U is the universal set, having the 100 elements, that is nothing but n of U is equals to how much, 100. Okay, if the set A and B are any two sets such that n of A is equals to 50, n of A is equals to what, 50, and n of B equals to 60, and n of b equals to what? 60. Then n of A union B, n of A union B is equals to, okay, they have given n of A intersection B. N of A intersection B is given equals to how much? 20. Okay, so what they asked is, they asked n of A dash intersection what? B dash. Okay, so they asked you, then options also given for you. Options are A is equals to 40, option A is 40, option B is 90, then option C is 20, and option D is what? 10 there. Okay, so if you use the formula, so that if you learnt 2 years back, you might be not remembering the formulas also, and you might have forgot the word concept also. So in these cases, what you have to do is, you have to take the what? Venn diagram there. Okay, so this is the what? Set A, this is the what? Set B, this is set A and this is set B. How many elements are there common? Intersection means common elements. There are common elements means 20. Okay, just you concentrate here. In total set A, how many elements are there? 50. Then already how much I have written here? 20. Then how much remaining? 30. Therefore 30 plus 20 is 50 elements which are present in the what? Set A. Okay, just you see here, n of b is equals to 60, means in the circle B you have to get what? Total 60, means already how much I have written here? I have written 20, means how much is remaining? 40 is remaining. If you add all the elements, then you will get what? A union B, n of A union B. That is nothing but how much? 30 plus 20 is 50, 50 plus 40 is what? How much? 90. Okay, so if you want to find this, so that we are having this by De Morgan's law, what we can write? N of A union B whole dash. N of A union B whole dash means the elements which are not present in this set. The elements which are present here is, so 90. So total elements are how many? So 100 elements are there total in this square box, but already we have seen here 90 elements. Then how many are remaining outside? Therefore 10. Therefore you can check here, 10 plus 90 is equals to 100. Means in A union B there are 90 elements. How many elements are not present here? Means so 10 elements. That is what they have asked, n of A intersection B. So A union B whole dash. A union B whole dash is equals to what? 100 minus of what? 90 is equals to what? 90 will get. So 100 minus of 90 is equals to 10 you will get. Okay, so this is how we are going to what? Use the formula. So this question, so which they asked in 2019. Okay, so next we will move on to the next question, so which is asked I think in 2014. Okay, so if you concentrate these two formula, then you are able to answer this kind of questions easily. So these questions will be asked and solved by using the what? Venn diagram. That will be easy approach for you. Okay, in the class of 60 students, so 2014 question. So 2014, in the class of 60 students, 25 students play cricket. Number of the students who play cricket is what? 25 students. And number of the students who play tennis is, number of the students who play tennis is 20. The number of the students play tennis and 10 will play both games. And the number of the students who play cricket and tennis is equals to how much? They have given 10 there. Okay, then number of the students who play neither. Who play neither means neither means not cricket also and not tennis also. Means who are playing not neither cricket also and not tennis also. For this question again I am going to take here Venn diagram. Okay, this is what? Venn diagram. So this is the what? Set of cricket people, and this is the set of what? Tennis people. So how many are there who play both? There are already 10 here. So but already in the group of crickets I have written here already 10. Means in this total circle there should be 25 students. Therefore already I have written 10 here, means how many are remaining? 15 are remaining here. In the set of the tennis, how many students should be present? 20 means already how much I have written here? 10 means 10. Therefore 10 plus 10 is 20 in T. Therefore 15 plus of 10 is C in what? Cricket group. Okay, total how many students are there? In total they have given that 60 students are present. In total there are 60 students are present. Just you check here who are playing cricket as well as who are playing tennis, all are present here. So how many elements? 10 plus 10 is 20, 20 plus 15 is 35. Then how many are remaining? 25 students are remaining. Therefore 25 plus 35 is equals to how much? 60. Therefore these are the 25 students who are not playing cricket as well as tennis. Therefore answer is how much? 25. Options, if you check, they have given that options are A is equals to 45, B is equals to 0, and C is equals to 25, and option D is equals to what? 35. Therefore answer you got here, so C. Okay, so this is how you can answer by using the what? Venn diagram in the what? Questions. Okay, next we will move on to the what? Counting technique of this relations. Okay, so so which is also very much important, counting technique of relations. Okay, just to concentrate here. So now what we are going to discuss is the number of the relations, number of the reflexive relations, number of the symmetric relation, and number of the equivalence relation. So as we know that relations are the subset of the Cartesian product of any two sets, right? So that I will consider here, let the set A is having n elements and the set B is having m elements. So that I will write m and n, m elements and l elements. The number of elements which are present in A cross B, that is nothing but the Cartesian product of any two sets, is equals to how much? M into n. Okay, so for example, if the both sets are having same elements, so n of A is equals to what? N elements, or you can take n elements. Therefore n of A cross of A is equals to what? N into n, that is nothing but what? N square. Okay, so these are the number of elements which are present in the Cartesian product. Then how many relations can be defined means how many subsets are there for this, that many relations we can what? Define. So that we know that number of relations is equals to 2 raised to m into n. Why? Because there are elements which are present in the set is mn. Therefore number of subset is equals to 2 raised to same. Therefore that is nothing but 2 raised to mn. Okay, this is about what? Number of the relations. So there are types which are discussed in what? Second PUC. Number reflexive relations, and here symmetric relations. So symmetric relations, here both. So just to concentrate here, so if they ask you if the relation is defined from A to A, if the relation is defined from A to A, where number of elements in the set A is equals to n, where the number of elements present in the set A is equals to n, how many reflexive relations can be defined is number of reflexive relations is 2 raised to n square minus of n. Then how many symmetric relations means 2 raised to n square plus of n divided by 2. Then how many relations which are both symmetric and reflexive is 2 raised to n square minus of n whole divided by what? 2. So these many number of reflexive relations, these many number of symmetric relations, these many number of both reflexive and symmetric relations. Okay, so just to concentrate here, now I am going to discuss about what? Number of the equivalence relations, so which is very much important, so we can answer them easily. Okay, number of equivalence relations. So we know that equivalence relation is the relation which is reflexive, symmetric as well as transitive, right? So number of the equivalence relation is if the set A is having what? If the set A is having elements 0, if it is having what? 1 element, if it is having 2 element, if it is having 3 element, if it is having 4 element, and if it is having 5 element, and it is what? So on. So here I am going to write the number of equivalence relations. So which technique I am going to use now is which is called as Bell numbers, right? So Bell numbers we are going to use. So here if the number of elements in the set A is 0, therefore number of elements, so A is the empty set, right? Therefore number of the equivalence relation is 1. Again you have to repeat 1 here. Okay, then already it ended with 1 means you have to start from 1. 1 plus 1 is equals to what? 2 here. Then already it ends with 2, therefore you start with 2. 2 plus 1 is 3, then for 3 plus 2 is 5. Okay, then again you start from the what? 5 here, therefore 2 plus 5 is 7, 7 plus 5 is 10, 10 plus 5 is 15. Okay, again it ended with what? 15, therefore start with again 15. 15 plus 5 is 20, 20 plus 7 is 27, and 27 plus 10 is 37, and 37 plus 15 is, so you can write 52. And it continues like this. I think next one will be equals to how much? 203. So again you calculate it and check like this. So if the set A is having no elements, that is nothing but A is the empty set, therefore how many equivalence relations? One relation. If one equivalence relation, if the elements are 2, then 2 equivalence relations. If the elements are 3, then 5 is equals to 15 is equals to what? 52. Okay, these many number of what? Relations will be used. Okay, so this is called as Bell numbers. Okay, that we are going to count this by using the what number of the partitions also, which will be what difficulty for you. Maximum they may ask you up to what 1 2 3 4 5, which will be what directly we can write by using this technique. Okay, so this is about what? Equivalence relation. If we go through the what in previous year question papers, so up to 2014, so there were no questions asked based on this equivalence relation. So there is one more point based on this equivalence relation I am going to talk. So if the set A and B are non-empty, A and B are non-empty, if the set A and B are non-empty, if the set A and B are non-empty, therefore there is a null relation, I will call it as, so I will call it as the null relation. So null relation is not equivalence, is not equivalence, not equivalence in the case of when A and B are having some elements. If A and B are empty relations, if they and B are what? Empty sets, if A and B are empty sets, therefore number of equivalence relation is what? 1 here. So remember, if A and B are empty relations, or else you can write if A is a empty set, therefore number of equivalence relation is 1. So you can write here A and B are non-empty sets, then number of equivalence relation is equals to how much? No equivalence relations. Any doubts? Okay, so this is how we are going to what? Discuss the things. Let us move on to the counting technique of the what? Functions, which is very important for the competitive. So I will start with the what? Again, just to concentrate here. So number of relations, from what? A to, if the relation is defined from A to B, where if the set A is having what? M elements, the set A is having M elements and the set B is having N elements. We know that if there are what? This is the what? Set of the relations. In that all will be not the functions. Some will be what? Functions. Some will be what? Not functions. So functions. Okay. So for example, if it is what? Total set of the what? I will consider the number of relations. So here all the relations will not become functions. Right? Try to get the point. Some will become function. Therefore, number of the functions is equals to how much? N raised to M number of the functions. But total number of the relations, we know how much? Total number of the relations is equals to what? 2 raised to Mn. Okay, so that in total number of the relations, so here I will consider 2 raised to what? Mn is the total number of relations. In this total number of relations, these many have become functions. Then how many are remaining? These many are remaining, which are the relations but not functions. That is nothing but number of not functions. Number of not functions is equals to 2 raised to Mn minus of N raised to M. N raised to M. So this is the formula to find the what? Number of relations which are not functions. Try to understand. So if this is a set of number of relations, in that all will not become functions. Some N raised to N will become functions. Among that, if I remove functions, the remaining relation will be what? Non-functions. Okay, so this is about what? Counting technique of the number of the functions. Okay, so next I will come to the what point, which is called as what? 1 function and onto functions. So one functions and onto functions. Okay, just you see here, just now we got to know that. So if the set A is having a n of A is equals to m and n of B is equals to what? N. Number of the relations is equals to 2 raised to mn. Number of the functions is equals to what? N raised to m. So now I am going to discuss about what? One functions. So one or also it is called as injective. So number of injective functions. Okay, so already we know that these many functions are there. In that, how many will be one means np, m number of elements will be what? One. Okay, so here I am going to discuss about not one functions, not one, or we can call that not an injective functions. Okay, so not one is also called as many one also they we can mention. So number of many one functions or not one functions. Already we know that these many are their functions, so that these many are their number of the functions n raised to m. In that sum will become what? One functions, that is number of np m. Then these many number of relations will be remaining, na? That will be what? Not one. Therefore in total number of the functions n raised to m, if I remove this number of one functions, then remaining will be what? Many one functions or not one functions. Therefore not one functions is n raised to m minus of np m. Okay, so these are the formulas you can use. Okay, one more thing I am going to discuss now about what one is. So necessary condition for the one set is, so n of A is less than or equals to n of B. For example, if they give this A is having what? 3 elements and this B is having what? 4 elements. Number of the one functions is 4p what? 3. 4p3, how you can write? 4 into 3 into what? 2. Therefore 4 3 is a 12, 12 2 is a what? 24 you can write. Okay, suppose if they ask you, so if the set A is having 4 elements, if the set B is having 3 elements, so don't collect directly, therefore 3p4 don't write. Why? Because so if you see this notation also, it is not possible, and already the necessary condition for the one is what? So number of elements which are present in B must be greater than this. Therefore in this case if they give like that, so you can write so it is not possible to write the number of one functions, or there are no one functions you can write. Okay, so this thing also you have to take care of here. Okay, just you see the previous year question papers. So they have asked one question. So okay, based on what? This number of one functions that we are going to what? See now. Okay, the question is like that. Okay, if the set A is having 4 elements, the number of elements in the set A is 4 elements, and the set B has 5 elements, and the set B has number of elements present in the set B is 5. Then the number of injective mappings means functions they have given that. So how many? We are knowing that 5p4. Okay, number of one functions, which question is asked in 2016. Okay, how you are going to write? 5 into 4 into 3 into what? 2. Therefore 5 4 is 20, 22 3 is 60, 62 is what? 120. Okay, options also they have given like this. So A, B, this is C, this is what? D. So 144, so 72 and 60 and 120. Therefore option D is correct. Okay, so this is what? Number of one functions. Okay, next we will move on to the what? Next number of onto functions. Number of onto functions. Number of onto functions. Suppose again I am going to consider the set A is having a m elements, so and the set B is having a what? N elements. Therefore number of elements you are going to number of onto functions by using the formula which is called as what? Partitions. Number of partitions, that is given by sum of k from 0 to n minus 1 raised to n, n c n minus of k and n minus of k raised to m. Okay, this is the formula to be used to find the what? Onto functions. So if you see this, there are no questions they have asked in previous years, right? So which will be not easy to calculate also. So one more thing is there, so that I'm going to discuss here is number of onto functions, number of onto functions or number of surjective functions also it is called as. If the set A is having n elements, if the set A is having n elements, in the set B is if only 2 elements, set B must be contain 2 elements, then there is a formula to find the number of onto functions. Number of onto functions is equals to 2 raised to n minus of 2, right? So this is the formula to be used to find the what number of functions which are onto when the in codomain the elements must be only 2. Okay, based on this technique, so they have asked one question in the previous year that we are going to discuss now. So just you see here in 2019, okay, so in 2019, so based on the number of onto function questions they have asked, they have taken the set A, the set A equals to x belongs to n such that x belongs to n such that x is less than or equals to 5, and the set B equals to x belongs to z such that x belongs to z such that x square minus of 5x, x square minus of 5x plus of 6 is equals to what? 0. Okay, just you see the what things here. So I want the number of elements which are present in the set A. Number of elements which are present in the set A means natural numbers less than or equals to 5 means there are what 5 elements. What are those elements? So elements will be 1, 2, 3, 4, 5. So if you see here, this is the what quadratic equation, right? So here don't sit on solving this, right, and don't sit on solving and finding the what the which are elements present in the what the set B, which is the waste of time. So which is the quadratic equations means we are knowing that always will get what 2 solutions, means there are what 2 elements present in the set. Therefore we can see here 5 and 2 here. Therefore number of onto functions is equals to how much? Number of onto functions is equals to how much? 2 raised to n minus of what? 2. So n is what? 5 here. Therefore 2 raised to n means 2 raised to 5 minus of 2. Therefore 2 raised to 5 is 32 minus of 2. Therefore answer is how much? 30. So if you check the answers, they have given the answers like this. So A is 2 and B is 30 and C is 23 and D is 32. So what is the answer? So answer will be how much? This 30. Okay, this is the question which is asked in 2019. Okay, so this is about what? Onto functions. Now we are moving to the what? The functions which are bijective. Bijective means the function which is injective as well as surjective, or we can call it the function which is 1 as well as onto is called as what? Bijective functions. Okay, we know that the necessary condition for the what onto bijective functions, right? So necessary condition is what? N of A is equals to what? N of B. That is nothing but in domain and codomain elements must be what? Same. That is only I am going to take the function f from A to A. If A is having what? N number of elements, here also n number of elements. Therefore number of bijective functions is equals to what? N factorial. So here if they ask you directly also you can write the answer, or else if they ask you to what? Find and calculate and find. If they ask you number of functions which are not bijective, means we are knowing that these many are the number of functions. How many are there? N raised to m number of the functions are there. For example here n raised to n functions are there. Okay, so here n and n, therefore number of the functions is equals to how much? N raised to n. In that I will consider that some functions will be what? Present which are what? N factorial. Okay, n factorial number of elements which are what? Bijective. Then how many elements are remaining? Means these many. That means how many? That is what? Number of functions which are number of functions which are not bijective, not bijective, not bijective. Therefore, how you are going to write? So that you can write n raised to n minus of n factorial. So these many number of the functions which are not bijective. Okay, so based on this also one question is asked in previous years. That is what I am going to discuss now is, if A is the set having the 6 distinct elements, the set A is having how many? 6 distinct elements, 6 elements. Then they asked you to find the number of the distinct functions from A to A which are not bijective. Which are not bijective means, so this function. Therefore, how many you can write? 6 raised to 6 minus of what? 6 factorial. Okay, so this is the numbers. These are the numbers which are not onto functions. Okay, I hope this video is useful for you. So if you refer this video, definitely you are going to answer 1 or 2 questions. So in sets, relations and functions, which is based on the counting techniques. Okay, see you tomorrow. Thank you.